John Wong and Danish Han. He have an interesting name, Danish Han, like Hannes Paruch and so on.
Okay.
But it's a family name, I guess. He's some sort of ruler in India or something. I don't know.
Yeah, the Mughal emperors.
Yeah. So without losing more time, because the time is short, yeah, a big applause for the deep dive.
Hello everyone. Good afternoon and nice to see you all for this Data Stack conference. And we are here to understand, get a hands-on on like live demo and understand a bit about Cloud Native PG and running Postgres on Kubernetes using our operator, which is Cloud Native PG. So I am Danish, and you can see through like certified CK, CKAD, and a DOK ambassador also. So what is a DOK? DOK is basically an organization which is very vocal about running your workloads on Kubernetes, which is called Data on Kubernetes. And you can connect with me using this scanner on LinkedIn. And yes, I am with ADB, which is a PostgreSQL company, and for more than 5 years. So I am a contributor to Cloud Native PG as well. And over to John.
Hello. We're good? Hello, I'm John. As you can see, I don't have as many certifications as Danish does, so I just put my LinkedIn thing there to fill the space. But yes, like Danish, I am a CMPG contributor. I've been working on CMPG, which is the Postgres Kubernetes operator, for 4 years. I have 8 years of experience with Kubernetes. 4 in a previous role as like a system administrator running production OpenShift clusters, and then 4 at EDB working on CMPG and our related internal operators. Yeah, and you can connect with me on LinkedIn as well.
Yes. So yeah, go ahead.
So the way we're going to structure the talk is I'm going to do an introduction and sort of talk about the stack that we're going to use. And then Danish is going to do a demo, a hands-on live demo after that. So I'm gonna cover the stack. Our stack is entirely open source. It consists of Postgres, Kubernetes, and then Cloud Native PG, which is the Kubernetes operator that combines those. Danish is then going to demo this by deploying Cloud Native PG, deploying a highly available Postgres cluster. He's going to configure tests. He's going to implement a backup strategy. He's going to perform a live recovery, which is exciting, and then associated day 2 operations. So, okay, first, Postgres. So, does anybody here not know what Postgres is? Okay. Next slide it up. So, okay, what is Postgres? Postgres is a database. EDB is the company that contains the largest number of contributors to Postgres. So EDB is sort of, in a lot of ways, like the Postgres company. They always tell us in our all-hands slides that Postgres is the most preferred database by developers, according to the Stack Overflow survey. So it's a great database. It has, I'm not going to read all these. I mean, this could be an entire talk. Like, what is PostgreSQL? This could be an entire year of study probably. But so for our purposes, PostgreSQL is the developer preferred database, completely open source, and yeah. Okay, so what is Kubernetes? So Kubernetes, you're probably less familiar with than you are with Postgres. So who here, as a show of hands, who here knows what Kubernetes is? Okay, so most of you. Okay, good. That's probably why you're at this talk. So the way that I like to think of it, I feel like there are a lot of ways that you could answer like the what is Kubernetes question. I like to think of it as an API for orchestrating container runtimes by automating things such as failover, service discovery, etc. So when people ask me what I do, and I say I work with Kubernetes, and then they say, what's Kubernetes? I say it's an API. If they don't know what it is, I'm like, it's an API. So this pretty much says that it's open source, of course, just like everything, owned by the CNCF and written in Go. So why would you use Kubernetes? You can run applications, you can run Postgres directly in Docker. Like you can just run it as a container with no orchestration. But that is, and that's fine for like doing experimental things or doing small like one-off applications. But eventually you will need some of the robustness that Kubernetes provides. You'll need the service discovery to connect your applications to one another. You'll need the self-healing. Like if you have a Kubernetes node go down, you'll need to use a Kubernetes primitive like a deployment or something to recreate your application when it fails. So why Kubernetes? For flexibility, self-healing, and security resource management. So this is a pretty simplified, but I mean accurate diagram of how like a Kubernetes, like a small Kubernetes cluster of like 3 nodes would look. You'll have the control plane that does all of the orchestrating, and then typically would be a node, and then you would have 2 worker nodes where you schedule pods onto. All of that. I mean, we could get in again. This could be a huge slide, but just for the purposes of this, when you're deploying an application on Kubernetes, typically you deploy a pod, and the pod contains the container that runs the application. Occasionally, you'll have 2 containers in a pod if those share the same lifecycle, like the container represents an application, and if those applications share the same lifecycle, they might be in the same pod if they're very tightly coupled, or they might communicate using the Kubernetes network and be in separate pods, just depending on their coupling. Kubernetes gets compared to, well, containers gets compared to VMs a lot. I think VMs are something that everyone is sort of intuitively familiar with because a VM sort of is just a virtualization of hardware. And I like to think of the differentiator between VMs and containers as VMs virtualize hardware, and containers, they virtualize the operating system. So containers are always going to be more lightweight, and VMs are always going to have more like stricter isolation, because a VM, you're going to have your own kernel, and a container you won't. So the idea behind that we had for running Postgres on Kubernetes was to make the experience be as Kubernetes and as cloud native as possible, and that's seen in the name of the operator, in that it's cloud native PG. It's not like trying to bring any traditional like DBA bare metal concepts to Kubernetes. It's trying to. The idea was to like have a way to run Postgres that is completely native to Kubernetes. And so in doing this, there are fundamental concepts that I think for a more traditional DBA would be different, or perhaps new. And so these are sort of the Kubernetes primitives, or the Kubernetes, I guess you could say, like core things that a DBA would need to know in order to work with our operator on Kubernetes. I'm not going to go through and read all these. Maybe I think they're good. So like I was saying, Kubernetes is an API. Is the way that I think of it. And I would say that a Kubernetes operator is a way to extend that API. So like Kubernetes would provide by default a primitive like a pod to schedule applications. And And then with an operator, you could add additional API endpoints to your Kubernetes cluster to then deploy new resources. Operator to deploy new resources such as like a Postgres cluster or Postgres backup, etc. So the way that an operator works is it has so it does a reconcile loop. It's like an event-driven reconcile loop in Kubernetes. And so what you're constantly trying to do is you define your state within the API, and then the operator will take that state and will try to declaratively get your application to the desired state through a state and a status setup. So it would have you define your state in the spec, and then you have the operator will read that spec, try to make things be in that way, and then if they are, we'll update the status. So it's like it's very similar to a state machine, I think, just like everything. Yeah, sorry, I kind of skipped around. So yeah, this is a good slide. So this is exactly what I was just talking about. So you would so like if the cloud native Postgres operator adds to the Kubernetes API, adds a cluster like a cluster definition. So now the Kubernetes API has an extension that it understands what a cluster definition is. Then you could create a cluster in YAML, which we'll show in the coming slides. You could define a cluster in YAML. The Kubernetes operator will read the YAML, see the desired state, so perhaps 3 Postgres instances, and then the operator will do whatever is needed to make the 3 instances come online and be healthy and connected and running and like receiving connections, everything that you need for Postgres. And it would track it would know like where it's at in that process through the status. I'm waiting on maybe a new microphone. Like talking about Postgres, talking about Kubernetes, talking about operators in a general sense. Cloud Native PG is the operator that it's fully open source, and it is the operator that we're going to be demoing today to show how to create and run Postgres. So yes, and this is pretty much what I was just saying. It's an open source operator. It was originally developed by the company we work for, Enterprise DB, which was really good. The approach was because Enterprise DB has always been, like I was saying, the Postgres company. That has always been like the core product is selling like services or selling like support on Postgres, and so Enterprise DB has a deep institutionalized, like very firm knowledge of Postgres and ability with Postgres and skills with Postgres. And so I feel like they were a great place to start Cloud Native PG because they were able to bake that into like how we built the operator to be cloud native, but also maintain all of the like deep institutionalized knowledge that we had from running Postgres as a support company for years. So Cloud Native PG was started by Enterprise DB. It has since been donated to the CNCF. It's fully open source. It was started by a separate company called Second Quadrant that was acquired by EDB. When I joined the company, it was closed source still, and we were on the path to open sourcing. I don't know if any of you have ever open sourced an application at your company, but there's more steps to it than you think. It's not like exposing a GitHub repo. There's a lot to it. But after a lot of work, we did get it done. We open sourced it, and then we did donate it to the CNCF the CNCF has levels for projects, like based on like the community and the popularity and the like centralness of the service. We're currently a sandboxed CNCF project, and hoping to grow that into an incubated status. But yes, so I mean, vendor neutral. It was started by EDB. The maintainers are the majority of the maintainers do work at EDB, but Cloud Native PG is owned by the CNCF. It's the CNCF's project. I think it has, yeah. Very good. I think we just crossed 7,000 stars on GitHub. So I think it was 7,000. So Cloud Native PG is more than just specifically an operator. The operator is the main part of like what is provided, but Cloud Native PG is sort of becoming an ecosystem. Very recently, there has been added the support to add plugins into the operator, which I think can be thought of sort of as like extensions within Postgres. So additionally, within the like Cloud Native PG ecosystem, there's the Cloud Native PG operator itself, and then there is a plugin to support barman backups, so like backing up your data onto S3 storage, which I think is going to be in the demo, right? Yeah, so we'll be seeing that soon. When you talk about operators, typically they are thought of as like being like at a level in terms of automation, really, I think, or just how much of the life cycle of the thing they operate on that they can control. It's a level 1 to 5. This is sort of, I don't know where the standard comes from. I see it a lot on like the enterprise Kubernetes deploys, like for OpenShift, they have this grade of like 1 to 5 for the operator. And Cloud Native PG is level 5. In that it automates, as you can see here, it automates a very large part. Once you configure in YAML, it automates a very large part of what you would be doing if you were a DBA, in terms of like running backups. Like you can do scheduled backups as like a primitive. You can do, it does failover automatically. It's highly available. Yeah.
So this is coming from operator framework.
Yes, exactly. This is, I think, operator framework is who came up with that. Yep. So we are level 5 on the like Red Hat certified catalog. So this is a very basic example of, well, so going back to when I was talking about Kubernetes as an API, an operator extends the API. This would be an example of one of the primitives that the Cloud Native PG operator adds to the Kubernetes API. So this is it adds the idea of a cluster, like Kubernetes by default would have like pods, deployments, replica sets, stateful sets, etc. The CNPG operator adds the idea of a cluster, and this is a cluster of Postgres instances. And you can see a very simplified version of a spec. This will work. Like this spec would be valid if you installed it. Typically in like in a production setup, you would have probably a bit more configuration than this. Yeah, this would be so you would create this. It would be a Postgres cluster. It would have 3 pods. The pods will be managed by the operator itself, not by some other Kubernetes primitive like a deployment or a stateful set. The operator will manage the pod scheduling. You'll have a Postgres image, so this one will have this. We also added to this example a node affinity. So like in a Kubernetes cluster, you might only have certain nodes that you want your Postgres workloads running on. This would, if you had those nodes labeled for Postgres, this is what that would do. And then 2 different storages, one for like your PG data and one for your wall. And okay, so yes, thank you to the maintainers. There are, I don't know how many maintainers, maybe 8 maintainers, maybe 7. most of whom, like I said, are at EDB, but there's a few at different places. If you want to contribute, it's an open source project, and that means we're always looking for more people to contribute to it. So if you have interest in contributing, I think it's a very welcoming community. I hope so. Always eager to help people learn. Very active on the Kubernetes Slack, I think. Very active in, yeah, I think it's just there now because we had our own Slack, but we got rid of it. So yes, and of course, thank you to EDB for the donation of the intellectual property. It's hard for a company to donate something that they spent a ton of money on developing and giving it to the community, but it's a great thing to do. If you're, I don't know if you can read, but if you want to scan the QR code to go to the GitHub, please do and give us a star. We do track how many stars we have. So if everybody here starred it, that would be, I don't know, maybe like 50 stars. That would be great.
And also maybe contribute to the testing when we build the some snapshots.
Absolutely. Okay, so that is it for me. I'm going to turn it over to Danish, and he is going to be doing a live demo. So give it up for. Oh, actually, does anybody have any questions before we go into the demo? Like anything about what we're going to show or none? Okay,
Yeah.
perfect. What kind of storage is supported is the question. So that's a very good question. We do support any storage that your Kubernetes itself can provision. So the way that we do storage is we will provision the Kubernetes native PVC, and then it will be up to how you've configured your Kubernetes cluster and your CSI drivers to provision whatever storage you have in your backend. So typically some type of block storage.
Yeah. And it is, yeah. Absolutely, and it supports all the cloud storages we have tested, and also Longhorn.
Yeah, so it's important. Yeah, the operator's interaction with storage stops at Kubernetes. So the operator will create a PVC, and then will sit and reconcile until that PVC is healthy. So then, as long as your Kubernetes cluster can create PVCs, then the storage will. You're saying, I mean, that would still be dependent on that would be like a Kubernetes cluster configuration thing. Like you're saying, like if you have local storage, like local to a node.
Yeah, let's imagine that we're in AWS, for example.
Mm-hmm.
So we have EBS which is attached to a particular availability zone.
Mm-hmm.
And if the operator is trying to share a pod in a different availability zone, when we're starting the podcast, for example, we're doing some kind of updates.
Yes, I see what you're saying.
Move that particular instance of the podcast to a different region, different availability region. The EBS is not going to be attached there because there is no way to move the regions. Is that going to be handled by the operator itself somehow?
So I understand you are asking moving your clusters from one place to another using the storage, right?
That's why you configure Affinity.
Yeah.
The Affinity, I think you can configure all the pods to be zone aware, and the scheduler will know to schedule the pod in the correct phase.
I'll explain that part. How do you configure things for production? Probably. Yeah. Yeah. Thanks, John. Thanks for explaining and warming up the session. Yeah. So let's go to the action. So probably I am going to use, we have created a CNPG playground so that it is very, very easy for the community to actually go and test the features. So you can scan and go to the GitHub and bookmark it for future use if you want to try it. So yeah, if you scan, and then I'll give 15 seconds and I'll go back to previous section. Okay, so how many of you run Postgres on Kubernetes? Nice. And how many of you run Postgres as a workload? And how many of you use Kubernetes? Perfect. Okay, so let's understand this part and then I'll go to the demo. So John already explained. I wanted to explain about the affinity part and how do you configure things in the production. Like, yeah. So you always uh, do the pre-warming when you deploy the databases, like, right? Like, I come from a background where I used to run the Oracle rack. You know how many days it would take? Like 2 days to prepare this whole setup, the real active cluster from Oracle. If so, going through this session, you'll understand how good the operator is deploying those. Now, when you select the nodes, you select based on your transaction and the workload, right? And then you try to put labels on it. You all know about labels on the Kubernetes, right? So let's say node is equal to Postgres, and then you put the same thing in the configuration. Like John explained, it's an extended API. So whatever Kubernetes support, we have integrated that with our operator. So like CRDs, it will go and check for those nodes which has the label as Postgres. If you define it, if you do not define it, it will go elsewhere. So try to define your node affinity, anti-affinity, whatever you want to, everything is supported. And then the pods will go to that place. Okay? Okay. So this is the requirement. So I'm running this on my laptop using a Kind. Kind is again a short version of running, like light version of running the Kubernetes on the laptop if you have a good setup. And of course, K3S and Rancher has one. So like everyone has their own setup. So yeah, I'm using Kind for this demo. So like I have used these many things and these are the requirements. You can take a snap of it so that if you use CNPG Playground, so you can have this as a prerequisite. Also, these are all things in the README of the Playground. Okay. Okay, so cloud native PG installation. Perfect. So I'm just trying to go in the namespace where it will be deployed. Perfect. This is the namespace where we deploy the, okay, so namespace, pod, these are Kubernetes terminology. So I'm assuming you guys will follow what I'm explaining, right? Based on the Kubernetes experience you have. So yeah, so if you take a look, this is a operator. And it is deployed using this one. So we have the latest release, which is 1.27.1. Right? So like if you go to the, like here, the cloud native PG page and just go to documentation and just explaining how you can navigate through the, yeah, and then you go installation and upgrade. So this is what I'm using there. So you just copy this and kubectl apply and the operator will be up. Based on your network and it will pull the image, of course. Okay? Perfect. So make sure your operator is up and healthy. And like we have given commands to make sure that, right? So you follow the documentation well. So it will ensure that your operator is, because operator is the thing which will manage all those. Like he explained, desired state and the actual state. Operator will always try to put the cluster into a desired state. That's what we want it for, right? And it is easing a lot of problems what DBA would be facing, right? Like self-healing is one of them. So to 12 a.m. in the night, you would not want your cluster to go down, right? You want the primary to switch over and then the cluster to be healthy. Okay, and we have CNPG plugin also, iPlugin, which will use for backup and other stuffs. And we have a tool which is CNPG plugin. We will use it for like demoing how we promote the primary. Okay, so perfect. Let's deploy a simple cluster, like very basic cluster. So this is a very, very, very basic cluster example where if you see there is a name, and this is of course our CRD, right? And this is kind which we have created using the operator. And yeah, this is mainly meant for the backup section. So like cluster example would be already existing, so we can rename it for, like we can say cluster example number 2. Okay. And font size, okay? Yeah. Sorry. Perfect. Okay, I'm using min.io as a S3 object store to like ship my wall files and backups. Okay. So let's apply the cluster YAML. Okay, let's. Okay, now we apply in this namespace. So it is created. Let's quickly take a look at the so it has not started yet. Probably will wait, and we can take a look on what we have in the while it creates. Okay, so yeah, the same cluster is created here. If you see, oh, let me go into the default namespace. Yeah, perfect. Yeah, so if you see, this is the cluster example 1. So understand. So what is cluster? So like we have deployed a Postgres cluster with 3 instances, the primary and 2 standbys, and we will understand what resources they have. Okay, and if you see like what is there in the definition of the cluster. And you can run all the commands what Kubernetes might have. So if you see, like I said, so it will have 3 PVCs, which is healthy, 1, 3, 4. Of course, 3, 4 I was doing some like experiment over there. So you will get it increase. So it was 1, 2, 3, but I deleted number 2. So it was 3 and 4. Okay, and the instances like this. Now the operator will always, even if you delete one, it will always try to bring back it to like the desired state, which is 3. Okay, and if you see, we did not. So if you take a look at this example, we did not define any PostgreSQL parameters, right? We did not define any of the PostgreSQL parameters. But if you see here, you will find some of them, right? So we have defined these are the basic things which we need to like run the PostgreSQL. We put it. If you define yours, there is a section. You go to the Cloud Native PG page, and you can define. I'll explain in one of the slide where you can change the configuration. And so you cannot change all the configuration, but you can change some, right? Whatever is possible. Yeah. So you see this, and then yeah, we are using like Barman for our backup and restores. And what we did, so earlier before 1.26, the Barman was integrated in the Cloud Native PG. Now we have went away from having that inside the Cloud Native PG to use it as a plugin. Like we have developed Cloud Native PG plugin as well, where you can run the Barman using that plugin to take your backups and restores. And you, for that matter, you can plugin is in such a way that you can like bring your own like tools and you can integrate with Cloud Native PG. Okay, and now, okay, let's take a look at what all things were like created. So one thing was cluster. Let's say get PO. Yeah, see cluster example number 134 running. Even you can run what all levels are there, on which node it is running, right? And you can do show levels, what levels were put like this, right? So like typically a Kubernetes admin would do something like this to understand the pods, and if you want to configure some monitoring, you would go and do something like this. Let's take a look at the services. So if you see, these three services are getting created, right? So you guys are able to see the screen. Should I increase the font? That's okay. Let's take a look at how it would look here. Okay. So look at these three services, R, RW, RO, and RW. Okay. And let's go here. This is what we deployed actually, right? Typically it will be a primary on worker node number 1, then the replicas on different node, and they will be in sync with the primary always. And we promote the most sync replica to be the primary. Okay. So if you see read write service, this is pretty much tied to the primary, if you see, because the write will always happen to the primary, and of course if you are connected you can always read, right? Read only service goes to the replicas like that. So we have segregated those things, right? So you do reads on the replicas and you do writes on the the primary. So if you want to configure your application, you can consume these three services to configure your application, maybe via load balancer, whatever, however want. Yeah, like you have the leverage, you can do selectors and like integrate these services, and you can take a look at this further. So let's say get service and take a look at this read write, and let's take a look what pod this have. So this has the cluster IP as 1096.24.162, right? And what pod it has? It has picked up the primary, like I said, right? Like in the example over here. Sorry, yeah. And then if you go here, you can see the IPs over there. So that's how you validate that you are doing the right thing, having your read-write services attached to your primary. So when you create the first instance, you always validate these things. Okay? So let's find out what 24162, the cluster IP. Yeah. Okay, another thing. Let's take a wider look. Okay. Sorry. CNPG is a tool which we have developed to take a deeper look inside the cluster. So if you run this, you will be able to find everything over here. So like you can also do like we did kubectl, get cluster and then cluster name and then -o YAML. And we go further with the CNPG tool. We try to define where it is, the walls and all, if anything is problematic in that. So if you see status cluster in healthy state, right? So we try to pick what type of image it is using. So this is using the latest version of the PostgreSQL. Okay. So if you see wall is archiving. Okay. Yeah. Let's take a look where it is archiving. So we have min.io, like I said. Let's take a look at the min.io. This is our min.io. This is our cluster. So if you see, we'll see a lot of walls getting shipped over there, right? And this is what it is saying, yeah. So, and we have backups also. We will go through the session, like we will see everything. Perfect. So far, any question? So service was one thing, pod we saw, and then we will try to look at PVCs. Okay. See these three PVCs which are attached to like our cluster number 1, pod number 1, 2, 3. So if you want to get rid of the instance, you have to clean up the PVC also. Just not deleting the instance like the pod will not help you. It will create problems. So when you are cleaning up your resources, clean the service, clean the pod, clean the PVC. That's it. And yeah, so if you see storage class as a standard, so like let's take a look at the what storage class kind gives by default. Standard, which comes from Rancher, but you can deploy a Longhorn. The problem with the other deployments is that they do not have a better integration like kind on Macs, or probably emulation. It doesn't work very well. So you have to look for other virtualization things to actually deploy Longhorn and all, right? So kind doesn't good that with Longhorns, but you can deploy Longhorn and use Cloud Native PG to create a PostgreSQL cluster. And if you want to take at what custom resources which we have created, like John explained, we are following operator pattern. So it will come to mind, right? Yeah. Why operator? Database, they are stateful, right? You need a consistency. So Kubernetes stateful state was not helping the database community. So we chose to be like operator person, right? We chose operator pattern. This way we had leverage to define lot of stuffs. Even we can expand our volumes. So if you're like I said, if you see here, so allow volume expansion, this is false, but you can increase the size as a offline increase in our cluster. So if you want, so there will be a downtime, of course, if you increase the sizes of those, like the replica will be created, like restarted, then the second one, then the first one, like that, right? The hot one is a different story. So cloud providers support hot volume expansion, so it will do automatically. Don't worry about it. Okay, but we try to keep the minimal impact. So we try to increase the replica first and then the primary. So when primary happens, so if it is required, we do a switch over. If it is not required, it will just sit like this. So your actual read-write operation will continue if you have defined it in your application from the primary. Okay, so always when you are deploying, so like the way I would deploy in production, I'll look for the storage class which supports volume expansion. GP3 has one problem. They allow only one expansion per 3 hour, I think, AWS, right? So you have to be careful when you are expanding those things. You do not like always make a like conscious decision and when to like increase those, right? So always be ahead. Do not increase something. Let's say you have exhausted 98%, and now it will not allow you further if you like you increase 10 GB and 98% was already filled. Let's say you have some problem with the wall files. It will fill up 10 GB again. And then you are stuck because GPT will not allow you, right? GP3 will not allow you to expand it further. So you have to be careful in like storage classes. So understand what you want to use and what features they provide, and then use those in our cluster definition, right? Perfect. So let's see how far we got. So I am following this, but I am following like playing around it. So this we did, this we created a cluster. Okay, we understood this. Yeah. So service PVC cluster, we all see. Okay, role binding and SA. This all will be there. So let's say, like typical stuffs, what would the Kubernetes provide? These are the roles. If you see role bindings, these all are required. So Yeah. Sorry, I'm not able to hear you.
CPG doesn't manage stateful sets as a higher level of object. It's managing pods directly, right?
Yeah, so we are, yeah. I mean, like, actually, can you ask it again?
So my question is it CMPG operator managing stateful sets, or is taking care of the pods and storage just by managing them directly?
Okay, we are not managing storage as such. So stateful set also we are operator. Operator pattern is different, and stateful set these are not stateful set. These are deployments. If you see. Yeah, please.
Oh, okay, I am back. I'll repeat the question, so make sure I understand it. Correct me if I don't understand it. But the question was, does the CMPG operator, is the underlying Kubernetes primitive that it manages, is it a stateful set or is it a pod? And that's an extremely good question. Because, so if you're not familiar with what a stateful set is in Kubernetes, it is a way to describe some number of pods that you want to start in a specific order, and it's meant for stateful workloads. So it would seem like that would be a good way to manage Postgres, would be with a stateful set, because Postgres is stateful. But no, we have a controller, we have a cluster controller that fully manages on its own directly pods and not stateful sets.
Correct.
And the reason we do that is because there are certain Postgres like operations that might require pods to come up in different orders, and so the resource that is defining the Postgres cluster needs to also understand Postgres. So it can't be a stateful set that's always going to do like 1, 2, 3, 4. It needs to be more Postgres aware, and we have that baked into the controller.
Yeah. Thanks, John. So yeah, I mean, like it's always the question like why we moved out of that, and yeah, it's like, but it's beautiful. So we have a leverage, a DBA. What do you think? Like it's making the life easy, the operator. So you have your control. Yeah. So like SA again, these are the clusters. So cluster example is one first cluster, and there are others. Okay, let's see. Yeah, pretty much we saw everything here. Okay, now you want to see, like, look into your databases, right? What is there? So let's run. So let's first figure out what is my primary. So we try to give as much information as which is useful. So if you see, first one is name, age, instances, and how many are ready, and then the status and the primary. This is very useful in getting a quick view of your cluster. So here, if you see cluster primary one, so let's connect to that. So typically, how do you connect on a Kubernetes? Like exec on it, right? So and just PSQL, right? And then you can do /du, right? So this is all app is one database, right? You can look through it, and then you can see the this is more beautiful than the other one. So this is how you run your Postgres queries over there. Like if you want to quickly take a look at glance, but we have connection strings, which is typically being used with those services. You can connect to the like these instances. So far we understood the cluster concept and the resources which we are creating, right? So are you guys following me? Or perfect? Yeah, of course. So secrets and all, like this is required. Like we have MTLS. All the pod communicate via certificates and MTLS. So we typically rotate those certificates, right? So you can get those information from, again, you can, let me get out of it. So these many secrets will be created when you create a typical cluster. Like when I says these many, you have to follow the cluster example one. So which will give you the idea, right? So app is used to connect to the app thing, right? And then CA, then the replication, right? So everything is created uniquely for its purpose, right? We do not want to mix things, if you see. So you can read about it. I'll leave this slide with the data stack page, and you can always reach out to us on the Slack or on the LinkedIn. We will help. So I mean, like, you can look through what is there, but it's fine. You can take a look. See, so you can take a deeper look on the secrets, how it is created, and probably the expiry date. Yeah, see, this is typical Kubernetes. That's what we are using, right? So the life cycle of this pod. So you will want to understand what is happening in the cluster, right? You will always want to look for the logs. Then you will always want to look what type of version I am running, right? These kind of things as an admin you want to understand, right? So let's take a look. Like typically with like 1,000 of instances running, you would like to know what is the host name of that company which is running the Postgres instance, right? These are the things, right? So let's run some of the examples. So let's take a look at the log. So of course, the primary one will have all the latest logs because all the write is happening over there. So yeah, see, and even if you remove JQ, so JQ is just to like let you visualize this, and then you have the log managers which will rely on those JSONs so that you can like attach them, right? So yeah, probably somewhere. So checkpoint, I did run checkpoint to ship the walls, right? So it will log everything. Probably it might have also walls, and I am finding if I have ran any query. Probably not. Just fine. Yeah. So this is how you take a look at the logs of the pods. So this is very, very useful. Again, if you see, it is very tightly coupled with the Kubernetes ecosystem. This is Kubernetes log, the command. There is a typo though. Let me fix that. Yeah. So you can use them directly. And then, yeah. So if you see, this is kubectl CNPG. CNPG is our tool which allows you a lot of operations, and we will go through those as we go in the session. So let's connect to this instance. So I did connected using the kubectl exec, right? Exec, then IT, and then I did PSQL. Similarly, if you just run, I would like, I will always advocate about CNPG tool. You use it very extensively if you are a cloud native PG user. It helps a lot. Even you can collect the logs with this, very detailed logs, right? You can go through the documentation. So see, in one command, you don't have to look for anything. You know the cluster and you're just there, right? And let's run this. Yeah, so did I did any typo? Should be fine. Yeah, cluster example one. This is our host name. So these are some basic examples. So typically the Postgres guys would like to love experimenting it more, like do something with it. Perfect. I mean, yeah, of course we want to test the controller. So let's take a look at what happens if we delete a pod, what will happen, like automatic failover, and we'll see promoting a replica. So these are typical operations of the operator to maintain the desired state. So you delete a pod, then operator has to understand that something is deleted. So you created a 3-instance cluster, but now it is 2. So operator will try to bring this up to a like instance 3s, right? And always look for the nodes which is available to schedule it, right? All those things happens in the behind, right? So it's typical Kubernetes. It will ask Kubernetes, give me a node. It will give you a node based on what definitions we have. Then the pod will be scheduled again. So let's find out the primary, okay? So cluster example 1, okay. And then let's take a look at cluster. Okay, so this is now in healthy state, and we will see the state changes. Again, a Kubernetes command. Sorry, 1. Deleted. Perfect. See how quickly it is started a failover. So it was in healthy state, and now it is waiting for the instance number 3 to come. If we see here, sorry. So the pod is initializing. So like I explained, so it saw that the number of instances is not 3. If you see, it is 2. So it is creating that pod for us, right? And the beautiful thing is, it did a failover over here, if you see. So your write operation is never impacted. Actually, it did a failover within second. So your most synchronized replica is now the primary, and which is cluster example 3. So what was your primary? Pod number 1. What is the primary now when we deleted? It is pod number 3, right? Which was the most synchronized replica. So this is the beauty of this operator. You, in the night, the primary got killed by something, OM killed anything. Yeah, and this pod is up and running, right? This is what we want in life, right? Like, do not wake up in night and the cluster is healthy. Perfect. So let's try to promote. So if you see all the commands we support here, it is available. If you do like kubectl cnpg, you can go through all the commands. Okay. Now I'll take a pause and let you understand how to like be ready for the production deployments. We have integrated FIO benchmarking. FIO is basically a tool to benchmark the storage. We have integrated that with the cloud native PG operator with the tool actually. With the tool, you can run the FIO benchmarks if you want to like know what type of storage you want. So when I say storage, so we typically in the Postgres, it is PG data and the wall, right? If you have more transactional data, you always look for good storage in the wall, right? And how do you know it's good or not? So you always run FIO. Then you have some benchmarks, right? And then at the end, when your cluster is up and ready for handover, you run another tool which is pgbench, which is again like default tool for load testing in the Postgres community. So Postgres guys will always know about pgbench. Then you compare pgbench data with the FIO. If that matches, it doesn't need any tuning. If that doesn't matches, you need to tune it further, like what type you want to use, right? So another thing, so after you have done this, then you identify your nodes, like what large node you want, high CPU, high memory, like that. Now another concept in Kubernetes is your resource utilization, which is your CPU and memory. So there is a limit which is defined. So you always define limit and resources as same. That guarantees that your pod will not be killed. So what happens in Kubernetes world? So Kubernetes kills them which do not have same, like if you see these things. Let's take a let's take a look the resources here. So we have not defined any resources here. So this pod is likely to be killed by Kubernetes first. But like if you see, go here. So we have go to the resource management. So if you see resources, request and the limits, both has to be same to guarantee that the Kubernetes will not kill this first. So Kubernetes is a shared environment, right? A lot of other pods will run, right? So they should not clash with each other. So you identify your node, you put taints on those nodes so that no other pod should go on that nodes, and then you put toleration on your cluster definition, like the pod should go on those nodes only, and then you define the CPU and memories so that you get a guaranteed QS while running those workloads. This is the way for production. So what you do, run the FIO, configure the guaranteed QS, like resources versus limit, both should be same, and then you run the PG bench, and then you should be happy. Okay? Then comes your scaling. So what will happen if the load increases? You always want to scale, right? Right or not? So we support scaling, like Kubernetes. If you run Kubernetes, scale replicas to like anything you want to. So let's see how many replicas we have. So 3 are running, 1, 3, and 4. And then let's see. So if you see cluster is a resource, so like if you see kget PO is a Kubernetes resource. So we have defined cluster as a resource over here. So if you do kget cluster, you will get, so if you see instances 3 and ready 3. So let's run the scaling. Again, K scale cluster, K is, okay, so K basically I created an alias to kubectl, right? To like quickly run the, it is kubectl, K, just don't get confused with K. It is just an alias. So let's say I want to do 4. Ah, I see. Okay, we have to define the cluster. Perfect. It says a skill. So let's see if it is coming up. So it is coming up. You see. So it was 3. Then we say number of replicas as 4. So it is quickly coming up. And if you see the status of the waiting for instances, and then it is healthy. So the healthy state will always change, but that doesn't mean your write operation is not happening. Healthy state changes, you have to look for further investigation why it is not healthy. So in our case, we already knew that we have scaled. Now the beauty of this scaling is now the number of replicas or the desired number of pods is 4, but it was 3. Number 4 was not there. So the operator sent a signal that, okay, you should be going back to like waiting for the healthy state, and the instances would be created, right? You are not healthy. Now when those are all up, like number 4 is up, so now the desired state and the number of count of the pods are same, it will go back to the healthy state, right? Which is what we want. And you can also scale down it. So let's say like you are done with the replica, so you can do like this. So yeah, again it will do the same thing. So let's see. Perfect. The number 5 is gone, which was created, right? So you scaled up and then you scaled down. So like we said, it is all coupled with the Kubernetes, right? And these all features which we have explored there to like integrated with our operator. So far, any question? Yeah.
Can you explain us more about day 2 operations, like, for example, handling regular analysis or configuring the auto vacuum? Is there something in CMPG that will help us to automate the auto vacuum and have better analysis from that? And second is that since the Postgre is extremely memory intensive, is there something that CMPG will help us to configure stuff like transparent huge pages or anything like that? Because normally those are the problems I've seen in the past, and also some of the considerations migrating from RDS to something managing Kubernetes. Thank you.
So I don't remember exactly in the cluster spec where it is, but you can define like you can set like your PGHBA conf. You can define that explicitly in the spec. I think but yes, that was kind of what I was alluding to as well when I was talking about how our cluster example is not necessarily representative of a what a typical production one would look like, because you'll probably have like your own Postgres parameters and stuff set to be like specifically tuned for whatever your workloads are. So yes, that is exposed somewhere in the spec. I think it's
You can explore, and probably some would be at the enterprise level, like transparent TD or something like that you are looking for, right? So probably you should get in touch with EDB. Like we have a lot of solutions which we expose it, but then like maybe out of scope for the current, but we can discuss it. We can take this up offline with you and discuss what problem we can solve for you. But it solves a lot of problems. So a lot of Postgres configuration, we expose it, even the, parameters. So whatever Postgres have, we expose it, whatever is configurable. So you can like shared buffer for that matter. It is configurable. So if you see right now, there is no shared buffer in this configuration, but I'll show you how to configure it. And you can also, so if you see let me show you, just allow me a moment. We have a lot of examples which you can go through. Probably if you go here and go to docs and go to source and go to samples. We tried to keep a lot of examples over here. So if you see example, this is what I meant. So you can, it is possible. So if you see, even if you see here, see, so we tried to cover the problems what DBAs might face. Like you took one example, which is a good question, right? So why not let's go take a look. So we have given those examples. So it is just not documentation. It is there, you can try. Yeah. So I hope you try and like. It's also out of box. Metrics is also there. So it will be at instance level, but I have to check. So every instance will be exposed to the Grafana. So there is a dashboard, and we have Prometheus also. So you can enable. So you have to enable a pod monitor. Then when that is enabled, it has a different configuration. So the basic one will. So you enable pod monitor because you need the monitoring, and then you look those instances on the Grafana using Prometheus and Grafana. That's also. So if you see this section, probably go to documentation. So see, so we try to cover everything. That's why we say it's level 5, right? So for production monitoring is important. So you can play around. So we have given a default dashboard, but you can like have your own, right? Perfect. Hope we answered. And thanks for asking the question. So which, yeah. Correct. That's how we help community, right? So we took a look, like deleting, checking the failover, yeah, scaling we took, and let me.
Are we over 3? I don't know.
Oh, probably we have time, so we can take a look. Okay. So yeah, failover we saw. Let's take a look at this slide. So, but we saw the live action actually. See, so this was gone. Primary one was gone. Then the read write was changed. Right? It was given to, in our case, not to 2. It was given to worker node number 3, if you saw. But this is an illustration. But again, it was the most synced primary replica, so it went to the number 3. And then it comes up, then it becomes the replica, right? And everything is up. Okay. This was what we did with deleting that pod. Then again, we can do a yeah, let's take again, like I said. So take a look at this, right? So what is our primary, which is cluster number, like pod number 3, right? So what we saw was a failover. What we'll see as a promotion to a primary. And we'll also put a check over here for the cluster. What is happening with the cluster in the status, of course. Then we say, so kubectl cnpg, the command which you saw. Then the following command is promote what cluster you want to promote, because you will have many clusters, and the instance number you want to promote. So you have to take a look at, like sometimes you will face like primary is down, but it was not automatically failed over. Then you can always go and promote the replica. So let's say, so it was 3, let's promote number 2, or switch it back to 1 probably. Let's see what was the, see, that was okay. If you see, that was a failover, right? And what you got here is a switchover, because we manually promoted it. So we switched the primary, and now the cluster is healthy state, right? So we promoted instance number 1, and we have now see pod number 1. So these commands are very useful in like catastrophic situations. So you can quickly bring your cluster write operation back on track, and then you can investigate with the logs. So why it is created? To help the DBAs to like quickly recover the cluster and then analyze the logs further. Okay. And like Kubernetes will always keep the logs. Like you have a log collectors where you can always push your logs. We suggest to do that, otherwise it will be a problem. And then you'll have policy to rotate it also. Right? Any questions? Perfect. So we tested controller, we saw feature of scaling and putting back. We saw failover and how quickly it was with a very low RTO, and then we saw switchover. Right? Now the beautiful backup. Right? So backup, like we always advocate to have the wall archiving enabled. You always ship the walls to S3 object store so that you recover it well. So, and then you take backups. If you are not configured those, then we have another solution which is volume snapshot, which you can like quickly create. So Kubernetes supports volume snapshot. We also support volume snapshot, and then we have given plugin, CNPGI plugin, which supports Barman Cloud, and then you can integrate with lot of other tools also. So right now, volume snapshot, with that you can create a backup and restore a cluster, do a PITR, and then you can have Barman Cloud, which you can again do the backup. So we'll see an example with the Barman Cloud over here, right? Okay, perfect. So let's take a look at this cluster. Like I said, we went away from the typical integration of Barman Cloud inside the Cloud Native PG operands to like isolating it. So you'll not see anything. Then you have to deploy the plugin. So there is a document available here. If you see, you have to follow this document. So this will enable you to configure your backups using the Barman Cloud. So if you see here, like these are its requirement, of course, Cloud Native PG. That's how we integrated it. And then the plugin, and then you can use any of these. So we have used MinIO. If you see MinIO, so get PO, you will see a MinIO pod running. So we had the earlier images. Now MinIO has moved out of giving the like community images. They have a licensing now. Perfect. So this all is configured, and then you go and take a look at the installation. So if you see these sections define like how you can configure the Barman plugin to take a backup and all. So these all are objects which is already created. Let's take a look. Get object store. So MinIO store which we created, which will use. So this has the definition of where your S3 bucket is. So -o YAML. So if you see, this is the destination. If you see, and MinIO local, which I created, which is running on, and then we have the credentials, which is access key and ID. So you can take a look at these credentials inside the MinIO pod. How? I'll also show you. So it's running on a Docker actually. So if you see, we wanted to explain how we are connecting remotely. Of course, I can always run the MinIO inside the Kubernetes, right? It's always useful. But Docker, again, it's different than the Kubernetes. So from Kubernetes, we are sending that to a Docker, right? The MinIO object is running on the Docker. Perfect. So if you if you want to know the credentials, you can always look into this. And then you can, perfect. So this is from CNPG Playground. We created this script for playing around. So just echo and traditional stuff. So CNPG is the username, and then you can similarly get the password. That's how I logged in. And we have defined this in our setup. So that's why. So default one is min.io admin, and this is how we have defined it. So again, echo, and so it will give you the password, right? Perfect. So the backup. So okay, let's get backup. This is our backup. So all of the, so if you see this, this is all defined as the CRD, custom resources, right? So I took 3 backups. Let's take another backup. Why not? I'm trying to quickly grab a, yeah, this is the command. Okay, so if you take a look at this command, again, I'm using the CNPG tool, then the backup, then the cluster name, and method is plugin. Like I said, we are using the Barman Cloud plugin, and then the plugin name which we are using. So you can have your own plugin, and then you use this command to take the backup. So if you see, backup is created, then go take a look here. Completed 7 seconds before. Of course, we do not had that much of data, so the backup was very fast. If you have data, it will take some time, but that's backup. So always take a base backup, then your wall archiving should be up so that you can restore the cluster. Right, so let's restore a cluster. Take an example. So we have this YAML, right? So let's understand this one. So yeah, perfect. Let's, for that matter, let's say data stack. Okay, image pull policy if not present. The image which we are trying to pull, you always, like, if not present, pull. If there is image, always use, right? And then this is the plugin name which we are using, and the barman object name which we will have, and then cluster which we want to restore. So let's run this one. Created, and let's take a look. So recovery is happening. And let's take a look at the, so data stack, setting a primary. So perfect. So let's wait for it to be restored, and then we will see what is there, if it is completely restored or not. So there was an error. Of course, image was getting pulled, and then let's see. Yeah. So see, it tried. Now pod is initializing. Now it is running. So there was an error, but it tried to solve the problem for it. Then again error, something, of course, problem. So again, you have to maybe, yeah, some error, probably it will come up. It's trying to do the recovery, what it will get. So yeah, when it gets up, it will be seeing something like, so this restore, it will be something like this. So if you take a, let's, yeah. Okay, and Perfect. And like (13 and 14), right? This is what we inserted while taking a backup. Now data stack is healthy. It came back, right? So if it is healthy, of course, sorry. Same, right? So what we had in source, right? We inserted some data into a table, which is 13 and 14 integer data. When we restored, we recovered it, right? So in any situation, you can always restore. Then we have replica clusters also. You can have a remote replica setup using Cloud Native PG, and in case of any disaster, you can promote your replica as the primary. Right now, that is a manual operation. You have to manually promote the replica as primary, but we have replica also, just to let you know. Then you can do a PITR on this. So for PITR, you insert some data. You have to look for those walls, and then you put the time which you want to. So there's an example on how you do it. Yeah. So if you see recovery target, you have to define the target time, and then it will be restored as a PITR, point in time recovery, right? So we understood all this concept. And the last thing would be to understand hibernation. There's another thing which we have given in Cloud Native PG is cluster hibernation. Let's say you're not using it, so you'll always love to hibernate, right? So you do not pay for anything. So let's hibernate this cluster. And it's just the command. You can just quickly do it by command. Annotated, and then this all will be gone. Terminating, see? Nothing. Where is the pod gone? Nowhere, right? Gone. It is hibernated. Let's see the PVC. Of course, PVC will be there, right? Otherwise, we'll lose data. So we just removed the pod, which was running as a load. We kept the PVC, and then quickly, like tomorrow you decide, okay, we want. So you can always go and remove the hibernation again. Then again, if you take a look at the pod, it will start coming up. Perfect, right? Beautiful feature to go with. Yeah, so it will come up on its own whenever, like, we can take a look. Yeah, so number 3 is coming, and then it should be number 5. So this one is fast because image was already present in the node. So I'd suggest you to have your images loaded on those nodes so that you have a very fast spin up of clusters and all. But anyways, it pulls, so don't have to worry about it. Now it is up. Okay, so shared buffers. Let's take an example of kget. Let's create another cluster and then define the shared buffer inside it. So this is let me get rid of this one, and also this one. I want like really basic thing. One. So k create ns and shared, and then we go to that namespace. Perfect, and then we create the cluster. Okay, it will quickly come up. Then you will understand the Postgres configuration changes, which is like comes in day to operation. So like those things are important, right? You know, in production, you saw something is not working, then you always go and change configuration tune. So observability important, benchmarking is important, right? Monitoring is important, and then so does your like tuning. So we gave these parameters to enable, so you can go and change, and based on your like requirement, you can change. So we'll try to understand put and see what's happened, what is happening to the cluster. We still have time, right? Just in time. So like just 1 minute and we'll be over. And it was good that we like carried the questions throughout. So yeah. Okay. So running. Perfect. So it is basic. Probably let's edit it directly. Again, we are supporting Kubernetes native APIs, so you can edit and change some parameters. So let's take a look at PostgreSQL. So these many, like I said. So you see there's no shared buffer. So let's add it. So you decided to have the shared buffer. Let's have it. Why not? Perfect. Perfect. So let's say 100 MB probably. That again, based on your requirement, you can have those. So if you see number three is getting restarted because that is a replica. It will not touch the primary. Now number 2, right? And then done. And then we log in and see if the values is updated or not. Perfect. So 100 MB, this is what we defined, right? And then you can also, let's change the value again. Let's say another problem happened, like you do not really want those cache. Now you want to decrease it, right? And assign it to something else. So you can go and where is the shared buffer? Yeah. So you say now I need it to be just 50. Again, same thing will happen. Same thing happening here because we changed the value which requires a restart. So there are values which requires a restart, but there are values which do not require a restart, right? Running. So let's, yeah. So then we 50 MB. Perfect. Now, yeah, if we have time, we can have like final questions, but I wanted to show the upgrades also. We have integrated a major version upgrade. So let's take an example. It will be really, really quick. I wanted to show this one. So in upgrade, I take a like image which is 16 and we upgrade to number 17. So let's do it. And let me have this instance 1 so that it will be really, really quick. Perfect. Pending, it should be up, pod initializing, and then completed. let's upgrade it to 17. So upgrade, we integrated the upgrade feature of the Postgres with Cloud Native PG. You just have to change the image, that's it. Operator will take care of it. And so I created this one. So let's say again change it to 1 and -1. So this one is 3. Now see the YAML definitions. That's how you do it. The same YAML. If okay, let's take what was the cluster example. So we have to keep the same name. Perfect. Same name but different image. So if you apply, it will say it has configured, right? That's how Kubernetes work. So let's upgrade. But before, let's take a look. Then do show version, typical thing again. Sorry. Why? What is the... Let's take a look in the... So what image we have? We have the 16th image. Perfect. Let's upgrade it. So K... Perfect. K get PO. So it creates a tag. So it deletes the previous pod, creates a hyphen tag that it is upgrading, and then if you see, it is saying we are upgrading the Postgres major version. Earlier it was just minor version, but we have integrated a major version upgrade also for the, like, if it is available, why not? That's an important thing, right? Sorry, I'm not able to hear you properly. If you can. Yeah, yeah. Yeah. Yeah, so let's take a look. Describe cluster. Now it has this image and then done. Then done. So how it is done? Let's take a look. So if you are asking question around this, probably you can take a look. This is what is happening in the upgrade. Say in perfect. Oh, I was doing a like select in the small. The select is in the capital. So okay. So yeah, that is it. Probably we reached to end of session. Thank you for staying and looking at this beautiful thing. You can always connect with us. I will leave this thing here. If you want to, if you miss the chance to connect, probably if you want to, you can connect with me and John. And if you have questions, we are around. You can connect with us. And thanks for staying and listening to me. Yeah.